Welcome to Budget Outlaws. My name is Andrew, and today we're going to talk about building a fuel injection system on a budget for your power goals. We'll talk E85 versus pump gas, fuel pressure regulators, fuel injectors, fuel pumps, fuel lines, wiring, and filters. Stay tuned. Since this video is going to go into a multitude of components, I'm going to put on the screen right now the timestamps for various subjects we're going to go over so you have a quick future reference after watching the video. Alright, fuel type. The first thing that you need to determine when designing your fuel system for your power goals is to determine what type of fuel you're going to run through your car. There are a lot of different types of fuel out there. And I'm not going to go into anything more than pump gas and the 85. If you want to look at ethanol, alcohol, or special race blends, please do your research on those specific fuels. I have no first-hand knowledge on them, so I don't want to misspeak on the subject. Now, pump gas is great, as it is everywhere, but it's limited in its octane. For the US, octane measurements are 91 to 93 for premium, and often found up to 100 and sometimes 110 octane non-leaded and 116 or more octane leaded at racetracks or select gas stations. Be aware that leaded fuel will destroy catalytic converters and possibly O2 sensors. The other commonly found fuel is E85. E85 is a gasoline that has an ethanol content of up to 84%. At full 84% strength, this fuel has an octane rating of up to 106, and it's typically considerably cheaper than gas. Win-win, right? There are some considerations. First is that ethanol strength changes with the season as well as the station. This means that it can vary from 51 to 84% ethanol depending on the station and the time. This is something that it's difficult to tune with specifically because it has different flash points. So be aware that your tune has to be somewhat conservative if you're running pump E85 if you do not have a flex fuel compatible ECU that uses a sensor to detect the ethanol content and adjust accordingly. Also, E85 has less potential energy than gasoline, so it requires more fuel to run the same, around 20 to 30% depending on the mix. Now, with this added fuel, you'll also get a lower combustion temperature and therefore lower exhaust gas temperature. What comes with lower exhaust gas temps is slower turbo spool. However, this can be compensated with more low-end timing to combat the lower EGT. But it's just something that I do need to mention. Now, tuners. At the point you're sizing everything or doing your research, you should find a tuner if you're not going to tune the ECU yourself. Find someone familiar with your platform you're using, as well as that has done similar setups to what you're looking to do. A local person is very helpful, but do not dismiss a qualified remote tuner with a good reputation. These people will be able to help you out with many of the details here, as well as a lot of the other things that you're not even thinking about yet. Also, as a general rule, stay away from universal eBay tunes or flash devices. One size does not fit all unless it's for your specific application and has a good reputation. Fuel pressure regulator. This is one of those things I would discuss with your tuner or ask your specific community on your car. Find out what they're going to suggest for going with your application. However, let's discuss this briefly. Let's say, for example, your factory fuel pressure regulator is 3 bar, and you have a rising rate factory regulator. That means that you run a 3 bar, or 3 times 14.5, which is PSI absolute, which equals 43.5 PSI. Your rising rate fuel pressure regulator will compensate fuel given your boost PSI. So if you're running 20 pounds of boost, you're going to see 63.5 psi at the fuel rail. In general, the higher the fuel pressure, the more fuel comes out of the injector. You can run a higher base fuel pressure regulator to get more fuel out without changing injectors, but that only means you're going to run a higher total fuel pressure, which will tax your fuel pump and will max it out sooner than if you were running a lower fuel pressure. So in my opinion, if you're planning on getting injectors for your setup, then run a standard fuel pressure regulator so you tax your fuel pump less, or a standard pressure for the regulator. Fuel injectors. Now, I'm not going to get into brands or which fuel injector to buy for your application. Do your research to determine which type your engine uses. For my application, which is an Audi 1.8 turbo, I used Bosch EB14 fuel injectors. Now, for sizing your injectors, there are a lot of different calculators out there that will do all the work for you. I'm just going to pull one up and put a link to it in the description. Let's do that right now. So, let's take my application. I'm running 4 cylinders, so I'm staying with 43.5 psi base fuel pressure regulator. Note that this calculator assumes a 1-to-1 rising rate fuel pressure regulator for turbo applications. I'm going to say 500 horsepower for my horsepower, and my duty cycle I'm going to put 80% to give me lots of headroom. Duty cycle is the amount of time that the injector stays open. The higher duty cycle, the higher the likelihood that you'll have an injector failure. Running much over 90% will likely cause long-term problems. 85% is nicely in the safe zone. Now, after all this, we hit calculate, and we have 2 sets of numbers on the bottom. Gasoline shows 984.38 cc per minute and 94 pounds per hour. E85 shows 1279.69 cc per minute and 122 pounds per hour. Now, let's say we ran 95% duty cycle. I could get away with a much smaller injector size, as noted here. So this tells me if we're running gasoline, I would shoot for 1000 cc injectors or 1300 cc injectors for E85. Personally, I found a killer deal on 1000 cc injectors, but before I ran them, I cleaned them and tested them, and lo and behold, they were 1300 cc injectors. So be aware if you're buying injectors used, it's a good idea to get them cleaned and flow tested. Now here's a budget tip. If you're planning on getting injectors for your car, consider the most amount of power you would ever put through your engine. I'm not talking about next year. I'm talking about 3 years down the line, 2 turbos down the line. Buy your injectors for that setup. I have zero drivability issues with 1300 cc injectors, and I know people that run much larger injectors than that with no issues. So the price increase with larger injectors is typically negligible. So there's no reason not to go with the largest injector you'll ever need if you're already getting a custom tune. If you're getting a canned tune or a pre-made tune for a specific injector, then by all means go with the injector paired for that tune, or you're going to have issues. On the subject of budget, you might have heard of decapping injectors. I personally don't recommend it, but it's an option for certain injectors for a budget race build. Just note that you'll have to have them flow tested when you're done to ensure they are within each other's tolerance. Another thing about injectors that I'm going to go into again is to do your research on what types of injectors fit your car. There are multiple types of connection points, lengths, styles, etc. that make things very confusing. Fuel pump. Now, the fuel pump is probably the first thing I hear people run out of when they're building a car because they simply save it for last or they don't even consider it. So let's address that. Now, depending on power goals, you might not even need to worry about replacing or modifying your fuel pump system. So the first thing that you need to find out is the limitations for your setup. Speak with your tuner as well as your specific community. They will typically help you out. Now let's take, for example, the Audi Volkswagen 1.8 Turbo. Most of the stock fuel pumps will start maxing out in the early to mid 300 horsepower range. I know I did. Now, most modern cars run a gas tank internal pump, so you'll have to find out which drop-in setups there are available for your setup. By drop-in, that means you replace the physical pump and maybe a few other components and put it back in the same location. Another option is to run an external pump. This is going to be required when you start to get into the higher power ranges, as the available drop-in pumps won't be able to support your needs. In this case, you can either run a pump inline as support to the in-tank pump, which will become a limitation, or in replacement. Since the OE pump is going to be operating at essentially zero pressure, it's going to have far greater flow than if it were supplying the injectors. That being said, there's a point where it won't handle the required flow. In the case of an external pump, depending on where that pump is, you may need to have some sort of priming pump, like a high-flow, low-pressure carb pump, but ideally the original pump so you don't have to buy something. Note that some pumps do not do a good job of sucking in fuel when they are above the fuel supply and need a gravity feed to start. One thing I need to make mention here is surge tanks. If you're doing a lot of track days, a surge tank is a relatively cheap but great option to prevent fuel starvation. It's essentially a tiny fuel tank, and your stock or carb fuel pump primes the tank and keeps it full. Then your primary fuel pump feeds the fuel rail from that small tank. So if you're running high G-forces, your fuel pump is constantly submerged. And if, for example, your main tank sucks in air for a few seconds, you'll still have plenty of fuel in your surge tank to keep the primary pump going without any hiccups. These are available in single and double fuel pump setups for whatever horsepower goals you have. I run one, and I love it. So, what size fuel pump do you need? Well, there are calculators for that as well. Fuel pump calculator. We'll go into this first one here by DW. And first we need to plug in the number of injectors, which in my case is going to be 4. The injector flow rate, which we calculated earlier at 1279. The base fuel pressure, we're going to go 45.3. Boost pressure. So this would be the max boost pressure that you're going to run, as it's likely where you're going to make the most horsepower. Let's just say 25. Then the fuel system type, whether it's return or returnless. Mine is return, and we hit calculate. So, I will need at least 307 pounds per hour at 69 psi. Now, this psi is very important because, as I mentioned earlier, the higher the fuel pressure, the lower the pump is going to flow. Let's take a look at some pumps, for example. So this is the DW350 inline pump and is rated at 350 liters per hour at 40 psi, which is the industry standard for testing. However, be careful, as some manufacturers do not follow this and will rate their pumps at a much lower or even zero pressure. So in our case, we're going to run right about 69 psi. So if we look at the chart, that's going to be right at 305 pounds per hour. So this tells me if I'm running this pump, I will probably start to run out of fuel as I get to my power goals, assuming I'm on E85. So I'll probably have to have my duty cycle on my fuel injector slightly higher than 80%. Remember when we said we needed less injector size at a higher duty cycle? This is why we can get away with this particular pump, as the injectors will simply stay open longer to accommodate our fuel needs. Now, as we finish talking about fuel pumps, we're going to have to talk about fuel lines. The first thing I'm going to mention is that if you're planning on running E85, plan to change out your lines. You need to have E85 compatible fuel lines to be able to accommodate, or else rubber inside those lines will deteriorate after time due to the ethanol. If you're running AN lines, you'll need to go for a PTFE line or similar E85 compatible line. Next is simply sizing. We need to make sure that we're running the appropriate size lines to meet our fuel supply needs. Let's pop up another calculator. We'll need to scroll down a little bit to see the data, but we have pounds per hour on this particular calculator. And on our fuel pump calculation, we figured it was 305 liters per hour. Now, a quick check of that shows that liters per hour is equal to 1.63 pounds per hour. So that means we need to multiply 307 times 1.63, and we get right at 500 in my case. So we're going to go 500. Now, 3/8 is a very common fuel line size for muscle cars, but in the case of, say, Volkswagen Audi, it's going to be 8 millimeter or 0.315. So let's make that change, 0.315. And now for the fuel length, I'm going to say it would be in the length of the wheel-to-wheel plus 50%, so I'm just going to leave it at 15 feet. And then I'll put the rise in the fuel line as 3 feet. Okay. We are going to leave the rest alone. And we're going to hit calculate. So, we see a total fuel pressure loss due to friction of 7.47. And that's probably too much. 8 pounds of pressure, 7.5. That's quite a lot to lose to the rail. So I would want to upgrade this if we're going for that much, and maybe go to a 3/8 line. Let's say, for example, we went with a 3/8 line. That dropped it down to 2.74, which is a much more livable number. So, personally, what I went with was AN 10 lines, or roughly 0.56 ID. Way overkill, I know. An AN 8 line would have probably been much better and cheaper in my case, but oh well. Now, we finish up the fuel lines, and we should talk about the fuel return line. If you're going to run a big monster fuel pump, you're likely going to see that the stock fuel return line, or specifically the stock fuel rail, won't be able to handle all the fuel flow returning back to the tank. And therefore, it would build up pressure in the fuel rail and eventually cause issues at low fuel demands or idle scenarios. Wiring. An often overlooked item is the actual wiring for the fuel pump. The factory wiring is 18 gauge, depending on your vehicle. The smaller the number, the larger the wire. And once you've determined your pump needs, you'll need to check the specs to find out the amp load to determine if you need to upgrade your wiring. Chances are you do. And here's how to determine what you need. So we're going to pull up our fuel pump specs again, and this time we're going to go by the maximum numbers just to be safe. Wire is cheap. So the maximum voltage input is 18 volts. We're going to go ahead and just use that. And then we look and see what the maximum amperage, and that is 17.5 on the system. If you wanted to go exactly per here, you could say, okay, we were going to go for 70 psi, and that's 14.6. But you're going to get spikes occasionally, and these are average numbers, so I would go based on the maximum that you see on this chart. And in this case, we're going to go 17.5 or 18 amps. Now, looking at our wiring size calculator, we're going to go 18 volts, 18 amps. Our voltage drop, we're going to allow for 5% voltage drop, because it's not that critical to get exact voltage. And then we're going to hit calculate. Oh, whoops, forgot the distance. So on our distance, we're going to go for 15 feet, same as our wire, or our fuel lines. Hit calculate, and we see 10 AWG. We'll see a voltage as a maximum drop of 17.1, so therefore we lost 0.9 volts with 10 AWG, assuming that 5%. Crazy, right? Now, you can use this for any time you're doing a wiring job to make sure that you're using the right stuff. Also, use relays. Relays are awesome. Use relays when you don't have the opportunity to run a dedicated power line directly from the signal source, or when that is cumbersome. A relay will allow you to run a large wire or power amp requirement through a small signal wire. Let's say, for example, you have a radiator fan that gets a signal wire from an ECU. That ECU wire is going to be very small, but the radiator fan is going to draw a lot of power, and therefore is going to have a very big wire. So you're going to need to put a relay near the fan and run a large power wire directly from a good source to the relay, and then from the relay to the fan. The fan won't turn on unless the signal from the ECU goes to the relay, and the relay triggers a connection between the large fan wire and the large wire from your power source. Finally, fuel filters. You should run a 100 micron fuel filter. The larger the number, the bigger the holes, aka the more stuff gets through, prior to fuel pumps, and a 10 micron between the fuel pump and the fuel rail. Make sure you get a big enough fuel filter, especially for those pesky 10 micron filters. I had one load up on me twice, and I now run a massive filter to keep, and I also keep spare elements with me. On a side note, if you're running E85, again, you're going to have to change out your filters to a non-paper filter. A stainless element or other E85 compatible filter is going to be required. I hope this has helped some of you guys. There's a lot going on with fuel injection, and hopefully some of this has taken at least some of the mystery out of how to go about sizing your fuel system. We've got a lot of great stuff planned in the next couple months, so please be sure to subscribe to see our future content. And if you enjoyed this video, please give it a like. The next video in the series is going to be about turbos and turbo sizing. There's a lot to cover here, so I might split this one up, as I probably should have split this particular fuel injection video up. I'm going to do about one of these type of videos a month, and then the rest is going to be videos on our build series. Thanks for watching, guys, and have a good one.